Addition with drawing place value blocks. So place value blocks are a great math tool to use when you're adding, subtracting, multiplying, or dividing, really. And they can be really helpful for counting, especially when you're starting with getting into bigger numbers. However, we may not always have place value blocks with us, and we can actually learn that by drawing them, we can be a little bit more efficient in solving our problems. So today we're going to be working on that, and we're going to do that by practicing finding the sum of 2,726 and 3,406. Now, I know from my math schema, when I see the word sum, that means I need to add. So before I start solving, I'm going to make a little plan or a model with my equation to help me know what I need to do. So I'm going to do 2,726 plus 3,406 equals S. And that S just represents what I'm trying to find, or the unknown, which is, in this case, the sum. So now I'm ready to start solving this equation. The first thing I'm going to do when I'm solving using drawing place value blocks is I'm going to represent each of my addends right here with place value blocks by drawing them out. So let's start with 2,726 first. So you can see up here, I have written out how you can draw each one of the place value blocks with a really simple, quick, and efficient drawing. So I'm going to do this. I have 2 in the thousands place. You can start drawing from your ones place or from your highest place value. It doesn't matter. I think I'm going to start with the highest place value for this number. So I'm going to draw 2,000 blocks. And instead of kind of wasting time trying to draw this really cool 3D cube, I just like to draw a T inside the square to represent the thousands block. So I'm going to draw 2 thousands blocks. It doesn't matter, you can do it colored, or if you just have a pencil, that's great too. So I have 2 thousands. I am going to do a different color for the computer just so we can see it a little better. And I have 700. So I have 100, 200, 300, 400, 500. And to stay organized when I'm drawing any of my place value blocks, I always like to draw them in groups of 5. That just makes it easier for me to count and stay organized. So once I get to 5, when I go to 600s, I'm going to start a new row. 700s. Okay. Next, I'm going to go to the tens place, and I have a 2 in the tens place. So I'm going to draw just a line here to represent the base 10 block. And I have 1 10, 2 tens, and then I have 6 ones. You can draw a square or a circle. I find it's a little bit easier to just draw a little circle. 1, 2, 3, 4, 5, 6 ones. Okay, now we're ready to represent our second addend with place value blocks. So I'm going to do 3,406, just put a little label here. Start with my thousands place again. And I have 3 in the thousands place this time. So I'm going to start with 3,000 blocks. Again, that T just helps me realize, and I draw them a little bit bigger as well, that those are thousands. So I have 1,000, 2,000, 3,000. Then in my hundreds place over here, I have a 4. So I'm going to go and draw 400 blocks. 1, 2, 3, 400s. Now I have a 0 in the tens place in this number, so I'm just going to leave it blank. I'm not going to draw any tens for this number, and I'm going to go to the ones place. In the ones place we have a 6, so I'm going to draw 6 ones. I don't need to show anything for that 0, just going to leave it alone. 1, 2, 3, 4, 5. Start a new row and do one more with 6. Okay, now that we've represented and drawn both of our addends, we're ready to start adding our two numbers together. Now with place value blocks, you could really add with either of the numbers, or you could start with your highest place value or your lowest place value. But when you start to do other strategies like standard algorithm or expanded form, you're going to start in the ones place. So I'm going to start in the ones place while we're doing this strategy as well. So I'm going to count all of my ones in both of these two numbers. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, when I get to a 10, because we have a base 10 number system, doesn't matter what place value you're in, we're going to need to regroup this number, and we're going to change it out. So if I have 10 ones, 4 from this group and 6 from this group, I'm going to make a group with 10 ones, and I am going to cross out this group, and I'm going to trade my 10 ones for 1 10. Some people call that regrouping. So now I actually have 3 10s, but I also have some ones left over. So I want to make sure I count those first. I have 1, 2 ones. I don't have enough to make another group of 10. So I like to just make a little note here that I have 2 in the ones place over here. And then I'm going to go and count my 10s. I have 1, 2, 3 10s, which is the same as 30. I'm just going to make a little equation down here. So I have 30 plus 2. Now I'm going to go on and count my hundreds. So 100, 200, 300, 400, 500, 600, 700, 800, 900, 10 hundreds, or 1,000. So just like I did in my ones place, once I get to 10 of any of these place values, I'm going to make a group of 10, in this case hundreds, because I know that 10 hundreds is equal to or the same as 1,000. So I'm going to cross out this group of 10 hundreds, and I'm going to exchange it for 1,000 because those two are equal. So just like I did before, now I have 1, 2, 3, 4, 5, 6 thousands, but I don't want to forget to look back at my hundreds place because I actually have this 100 left over. It's not enough to make another group of 10, so I'm just going to add that into my equation down here. I have 100, and then I also have 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. So this is my number kind of in expanded form. Now, some students, when they get to this step, can actually do and add all of these numbers up in their head to find their sum. That's great if you can do that accurately every single time. But I would encourage you, just in case, it only takes another probably less than a minute, to write out an equation however you choose. I'm going to write it out just kind of stacking it or with standard algorithm, just to double check and make sure that my sum is accurate before I finish solving. So 6,000 plus 1,000, or 6,000 plus 100 is 6,100. Those are pretty easy to add because there's a lot of zeros in these numbers. Then I'm going to add my 30, and I like to add them one at a time, again, just so I'm really accurate and I'm not making any mistakes trying to add too many numbers at the same time. 6,130. And then my final sum plus 2 equals 6,132. That's my final sum.